Isolating the variable term means getting it all by itself. So that means you're using addition or subtraction to move this constant term over. And then just one x, or just one variable, means you want just one m. So you have to divide or multiply to get just one m. So then we'll have m equals whatever, and then you've solved it. And notice there's check your solution, because in algebra, on your tests, very frequently, you can go back and plug in your number and see if you did the problem right. Okay, so the first step is isolate m. So I'm going to be adding 6 to both sides. Okay, so then I'll have negative 5m equals 15. Then my second step is just 1m. So then I'm going to be dividing both sides by negative 5. So that I get m equals 15 over negative 5. Well, that's negative 3. So checking your solution just means plugging the negative 3 back in everywhere you see m. So then you have negative 5 times negative 3 minus 6 equals 9. Okay, so that's positive 15 minus 6 equals 9. And there's your check. Okay. So the first step, isolate x. Isolate your variable term. So we're going to, what are we going to do? Add 4 to both sides. So then we get 15 equals 3/7 x. Now, some people show this step. I tend not to, especially, you guys have done this, a lot of this stuff you did last year. So, but if it helps you to show that step, that's fine. Now, I need to multiply by something to get just 1x. What can I multiply by?
The reciprocal?
The reciprocal. So I'm going to multiply both sides by 7/3. And I'm going to put my 15 over 1, just because it makes multiplying the fraction a little easier. Now, when I multiply this by 7/3, that goes away, right? It becomes a big 1. So then I just have x. Now, can I simplify this? So I can simplify, right, because I can cross-cancel. Both of these are divisible by 3. So this becomes a 1 and a 5. So 7 times 5 is 35, with the denominator of 1, so it's just 35 equals x. Okay. And then checking our solution, well, that means plugging the 35 back into our original equation. So 11 equals 3/7 times 35 minus 4. So, what's 1/7 of 35? What's 35 divided by 7? 5. So 3/7 is 15, right? Okay. So then this is 11 equals 11, so it worked. So the first thing, I'm isolating my x term. So I'm going to subtract 8 from both sides. So I have 2/5 x. Okay, so I've subtracted 8 from here and 8 from here. So I don't have anything else on the left. Negative 12 plus negative 8 is negative 20. But this isn't good enough. I want just 1x. So I'm going to multiply both sides by the reciprocal of 2/5. So that then, if I multiply both sides, and the steps down here, but I'll show you up here. If I multiply both sides by 5/2, then this goes away. And then I just get x equals negative 20 times 5/2. All right? Now, how do I do this? Negative 20 over 1 times 5/2, that's the same thing. Can I cancel anything here? The 2 and the 20, that becomes a 1, and that becomes a negative 10. So then this is negative 50 over 1. So this x just equals negative 50. Does that make sense? And then you plug your negative 50 back into the original equation to check your solution. So you have 2/5 of 50 plus 8 equals negative 12. So what's 1/5 of 50? What's 1/5 of 50? 10. So 2/5 of 50 is 20. Oh, this is a negative 50. Of negative 50 is negative 20 plus 8 equals negative 12. Oh, that works. Negative 12 equals negative 12. So we're done. Decimals. What if I multiply both sides of this equation by 10? So I'd get 10 times this is just negative 24, right? 10 times this one is just 13. And 10 times this is just 85. And that looks a lot more like our other ones. So if you hate decimals, multiply everything. In this case, multiplying by 10 works. If you had 2 decimal places, you'd have to multiply everything by 100. The only thing is, if you have a number that doesn't have a decimal, you need to remember to multiply that one by 10 too. Absolutely everything has to be multiplied by 10. Okay, so now we've got this. Now my first step is to subtract that 13. Okay, I'm going to show that step. And so then I get negative 24x equals 72. So then I'm going to divide both sides by negative 24. So then x equals, I'm going to put the negative out front because I don't like it in the denominator, and that just goes in 3 times. And you can kind of estimate it, and then you can either do the long division or do multiplication, like guess and check, see if you're right. So then you get, do you guys want me to do this one with the decimals, or should I multiply by 10 to clear them out? Any preference? With the decimals.
You can do both.
So you can try it, yes, good. So now I'm going to add 5.2 to both sides. All right, so then we get 3.5x equals, well, if you remember adding and subtracting real numbers, you can take the absolute values, and since we have different signs, do you remember this? You can subtract the smaller absolute value from the larger absolute value, and then the total will have the sign of the larger absolute value. Remember this? And so that was in an earlier lesson. So 15.7 minus 5.2, because I'm subtracting this absolute value from that, gives you 0.5, gives you 10.5. And it's a negative because our larger one is negative. Any questions on that? That goes back to what we were doing a little earlier, a couple weeks ago. All right. So then I need just 1x. So I'm going to divide both sides by 3.5. Okay, so then x equals, well, it's going to be negative. How many times does 3.5 go to 10.5? Give me an estimate. 2? 2 would be 7. 3 would be 10.5. So it's exactly 3. Okay? So there's your answer. So you guys do the U-try. So you can either multiply by 10 to get rid of your decimals, or you don't have to. You got it?
Yeah.
What'd you get?
4.
Okay. Where are my notes? I need my key. Almost.
Negative 4?
Negative 4.
Oh.
That's what I mean. Okay. So I'm adding 4.1 to both sides. So that gives me 1.5x. We're adding 4.1 equals, if you add 4.1 and use that same method we used over there, 10.1 minus 4.1 is 6, and it's a negative because the 10 is bigger. So then you have x equals negative 6, you can put the 0.0, you don't have to, divided by 1.5. Well, right away I think in my head, 1.5 times 2 is 3. 3. So 1.5 times 4 must be 6. So this is negative 4. Okay. If you want to, if it's easier, you can just divide the 6.0 by 1.5. And then when you move your decimals over, this is just 15 into 60. And that goes 4 times. Okay. All right. So now we've added a new step. Because we have more than one term sometimes. And so before you do your isolate and your just 1x step, you're going to combine like terms. And when I say combine like terms, I mean just the ones that are on the same side. Because these next two steps take care of the ones that are on the opposite sides. So combine like terms that are on the same side. So these are like terms. And negative 3x plus 12x, well, negative 3 plus 12 is 9. So 9x equals negative 72. All right. So then we divide both sides by 9. So x equals what? Negative 8. Okay. I need to combine like terms. 4x minus 16x, well, negative 16 plus 4 is what? Negative 12. So this is a negative 12x equals negative 24. What's my next step? Divide by negative 12. So then I get x equals 2. Negative divided by a negative is positive. So you try it. What'd you get?
5.
Almost.
Negative.
Negative 5. Okay. So we're going to combine these. That gives us negative 7x equals 35, right? Because 8 minus 15 is negative 7. Then we're dividing both by negative 7. So that gives us x equals negative 5. When I say it out loud, it's verbal. The value of y, these are tricky, is 6 more than 3 times the value of x. Here's what I do. Okay, I know I've got 3 times the value of x. Okay, that's just 3x. 6 more than that is plus 6. The value of y is this. So y equals that. So I just start underlining. But I start with something, it would be easy to say 6 more than 3, but then you've missed the times the value of x part. So be very careful in your reading. So now it says, we've got our equation. Now we're finding the value of x when y equals negative 3. So if I'm going to substitute the negative 3 everywhere I see y. So negative 3 equals 3x plus 6. Now we just have a 2-step equation. So I need to isolate my x term. So I want to subtract 6 from both sides. Okay? Negative 3 plus negative 6 is negative 9 equals 3x. Then what's my next step?
Divide.
Divide by 3 because I want just one x. 3. So x equals negative 3. So you try this one. Yeah.
I think we got.
What'd you get?
Negative 3.
Negative 3? Okay. So the value of y is 8 less than 4 times the value of x. Well, there's 4 times the value of x. 8 less than that is that. And the value of y is this. Okay? Find x when y equals negative 20. So I'm going to put my negative 20 where I see y. All right, now I'm isolating my variable term, so I'm adding 8 to both sides. I said I wasn't going to show this step, but I think it helps. So negative 12 equals 4x. And then my next step is to get just one x. So x equals negative 3.